So section 4.2 events. So this whole section is about introducing more information about events. What are events? Especially when it comes to a deck of cards. As you can see, we have a total of 52 cards, 13 each. 13 times 4 is 52. The first row is spades, the next one hearts, diamonds, and then clubs. Okay, and then what we need to do, why do we have this? Because this can be applied a lot in when we talk about events. We can talk about events. This helps a lot. So in the previous section, we introduced what an event is. It's basically a collection of outcomes that can be obtained from an experiment, or it can be like a subset or a sample of a what we call sample space. So the sample space is a collection of all possible outcomes. When you run an experiment, all the outcomes get collected in one set called sample space, and the event can be as part of that, or a subset of it, or a sub event, or sub sample, whatever you want to call it. Now here, when we work with events, more than one event at the same time, it helps to check out how can we arrange the events, how can we organize it to make things easier to work with. So usually the first thing I want to start with is, let's call this is the sample space. Some people call it universal set. This one contains all the stuff, and we have within this we have event E. Event E. What is within the sample space but not in E, is called it not E. And in other words, some people, we can call it the complement of E. And if you like notation wise, the book doesn't do it here, but it's E prime like this, or E to the C for complement, or E bar. That's not E. This is not E. Okay, that's a complement of E. So it's kind of like, as an example, let's say you talk about rain, no rain. No rain, no rain. So rain is the event, no rain is the complement of that event. Sometimes, that's one thing. Sometimes you're talking about two events that they share something in common. And so how do we represent this? To represent that event, we use what we call Venn diagrams. Okay, Venn diagrams, how do they work? They are on the left side, but let me explain it here. So say we have event A and event B. This is event A, event B. The two events, they share something in common. That common is what it goes in here, in the overlapping. And this, to represent this, we call it A and B. Means something that you can find both in A and B. And if you'd like to see an example, let's say event A contains these outcomes 1, 3, 4, 7, 10. And then B contains these outcomes 2, 3, 5, 6, 7, 8, 9. Then what's in A and B? A and B is what you find in both of them. Well, we can look. What's in? Is 1 in there? No. Is 3 there? Oh yeah, 3 is in here. Is 4 there? No. 7? Yes, the 7 is here. 10? No. So what goes in A and B is 3 and 7. 3 and 7. That's what goes in A and B. Now if I take the same Venn diagram, this is event A, event B. If I shade everything, combining A and B together, that's called A or B. Okay, A or B. The other one was A and B, and where it's overlapping. Or means combining. So when you combine everything. Or when you combine. So again, for A and B, that's when both A and B occur at the same time, when A and B overlap or they share something in common. They share something in common. So let's look at an example related to the deck of cards. Let's say we have an experiment that we randomly chose a deck from the 52 cards deck. Let's define A be the event that the card selecting is the King of Hearts. B is the event that the card that we select is just a king, so it could be any king. C is the event that the card we selected is a heart, and D be the event that we're selected is a face card. Okay, now we would like to determine each event. Determine each event. The first one, not D. Determine not D. So what does that mean, not D? Not D. So what's not D? So we have a total of 52 cards. Not D means not a face card, because D was a face card. Well, how many of them are not a face card? Well, let's look at the deck of cards up there. That's why we have that picture here. How many are face cards? 1, 2, 3, and each one 3. 3 times 4, 12. So this means there are, event D has 52 total cards, and not face, the face are 12. So that gives me 40 not face cards. Is that okay? If so, what about B and C? B and C. So how many in B and C? What do they share in common? How many cards are being shared between B and C? Or what does this event is? What is it? Is the event that both B and C occur. Okay, so what is B? B is when you select a king, and C is a heart. Right? C is a heart. So what is it? How many? So this is a king, and this is when you select a heart. How many kings in the heart? There's only one. So there's only one single thing. So if you take all the hearts and all the kings, the only thing that overlaps, it's only one of them. And I can show you that on deck of cards. So the second row is the hearts. And then so you can go like this. These are all the hearts, and these are all the kings. They only overlap in one of them. So that's why it's one. And why did I talk about overlap? Because it's and. It's and. And means overlapping. What about if they say I take the same one, just change and to or. And to or. So how many do we get in this case? Okay, so or means you are going to combine all of them together. All of them. We're going to combine all of them together. So how many do we get? Well, how many kings are there and how many hearts are there? We know there's 12 hearts. There are 12 hearts. And B is the kings. So how many kings are there? 4 kings. So what would be the total? What would be the total here? Sorry, there's a 13 here. 13. So 13 and 4. So watch something. Some people do 4 plus 13 and they write 17. Let me go back up, show you something here. So this is the heart that when I selected, and then the kings. So when you go with the hearts 13, so there's 13 here, and then the hearts, I'm sorry, the kings are 4. So when you count the 13 hearts, and then you count 4 kings, you are counting this one, the overlap, twice. You can't count it twice. So you already counted with the kings or with the hearts. You can't count it with the kings. So that's why you do write 4 plus 13, but you minus that overlapping king. So that gives only 16, not 17. If that is okay with you guys. So that's what the relation between these events and or what events means. Now we can talk more about more relations between events. What do we have? Well, some events they do not share anything in common. Okay, nothing in common. If they share something in common, then we can use Venn diagrams, and that's what they share in common. What about if there's nothing in common? Okay, and that can happen in millions of ways. If nothing in common, then this is event A, event B. Then it would look like this: event A, event B. Nothing in common. They do not overlap. And this kind of events are called mutually exclusive events. Mutually exclusive event. It could be 2 or more that they do not overlap. Okay. Now what happened if we have 3 events? So let me draw them in sets like this. A possibility could be like this: A, event B, event C. In this case, those are called 3 mutually exclusive events. Now what about if 2 events overlap and the third is not overlapping? So you have event A, event B, event C. See, they have something in common, but not all of them at the same time. You don't have anything, not all have the same thing at the same time. So what do we call it in this case? We call it 3 non-mutually exclusive events. And what about if all of them, they have something in common? Something in common, which is going to be this one. That's where they all overlap. Let me highlight it with yellow. This highlighted part, that's where the 3 events overlap. Call this event A, event B, event C. So the highlighted part, the yellow part, is called A and B and C, like that. That's where all of them, they overlap. Again, these are called, 3 non-mutually exclusive events. So do you guys see that? Like how the 3 overlap? When they overlap, that region where they all overlap, that's called A and B and C. You can this can apply to 3, to 4, to 5. It's the same thing. Let's look at an example on this. Let's say you draw a random card from the 52 deck of cards and define each event. Event C to be, C is the event, the card selected is a heart. Okay, D is the event, the card selected is a face card. E is the event, the card is selected is an ace. F is the event that the card is selected is an 8. And the last one is an event the card selected is a 10 or a jack. That makes it more fun. Last example. So, which of the following collections are mutually exclusive? Which ones? Number one, C and D. Do you think this event is mutually exclusive or not? Well, to answer such a question, you ask yourself, do these two share anything in common? Can a card be a face card and a heart? Yes, it can. So this is not mutually exclusive. Since you can have a heart that is also face, or face that is a heart. What about another one? C and E. C and E. What is C? C is a heart and E an ace. Can you have a heart that is an ace? Yes. So not mutually exclusive. I'm going to write ME, means mutually exclusive. What about D and E? And then we're going to look at D, E, and F at the same time. So can a card be D and E? What is D? D is a face card and E an ace. Can a face card be an ace? No, a face card is not an ace. So they are mutually exclusive. Remember, the ace is not a face card. The face cards are only the 12 cards on the right side of the deck of cards in the picture I showed you. Can it be D, E, and F at the same time? Let's check. D is a face card, an ace, and an 8. No way, that's impossible. That's impossible. So they are mutually exclusive events. Mutually exclusive. Now, one last one. Can it be D, E, F, and G? Okay, D, E, F, G. D is a face card, an ace, an 8, a 10, or a jack. So keep in mind, they don't all have to share something in common, like all one thing in common. At least two of them, they have to share something in common. Because if you look at the picture again, in the middle picture, those are non-mutually exclusive. But because A and B, events A and B, they share something in common. So that's what we do for this one. So they talk about the last events, D, E, F, and G. Well, face cards is not an ace. Face card is not an 8. What is an ace an 8? No. Is an ace a 10? No. What about face and jack? Does that work? Yes, face card and jack. Jack is a face card. So since they overlap here, then they are not mutually exclusive. So since the jack from G is a face card from E, then they are not mutually exclusive events. Is that okay? Any questions about this?
No question.
Yes.
No, I don't have a question. Just answer.